Electric motors use the forces of attraction and repulsion between an electric current and a magnetic field to create turning movement. Motors vary in size, from microscopic actuators inside electronic gadgets to giant power plants that propel large ships. How an electric motor works. In many motors, a coil of wire moves through the magnetic field produced by a stationary magnet. When current flows through the coil, it becomes an electromagnet with north and south poles. The coil swings around to align its poles with those of the permanent magnet. A commutator reverses the coil's current every half turn to switch the coil's poles and keep it spinning in the same direction. The coil is connected to a driveshaft, which transmits the motor's turning force to components, such as wheels. Step 1. Current flows into the coil. An electric current flows into a wire coil positioned between the poles of a permanent magnet. The coil becomes an electromagnet. Step 2. Wire coil turns. Repelled by the magnetic-like poles, the coil turns away. After a quarter turn, the unlike poles attract, forcing the coil into a half turn. Step 3. Reversing current. The commutator reverses the current's direction. This switches the polarity of the coil's magnetic field, so its poles are again repelled. Step 4. Poles repel. The coil continues to rotate, repelled and then attracted by the permanent magnet as the current is continually switched. Universal motors. In a universal electric motor, the permanent magnet is replaced by an electromagnet made of a number of windings of wire through which current can flow. This produces a magnetic field, inside which a coil, called an armature, rotates. Both the armature and the wire windings surrounding it receive the same electric current because they are wired in series. This means a universal motor can run on both DC and AC electricity. An example of this would be a power drill. Many power drills feature a universal motor that offers high levels of turning force, or torque, and allows the user to select the best speed needed to drill. What happens in a power drill to get it to work? There are 4 major parts or activities that enable a motor to work. As an example, we'll look at the mechanics of how a drill works. The first part is the power supply. AC power runs through a cable into the drill switch assembly. Electricity will flow to the universal motor only when the trigger switch is pressed, and the circuit is completed. In some drills, the power is provided by a rechargeable battery. The second part is the magnetic charge. The electricity reaches the stator windings and armature coil and generates magnetic fields. Both receive the same current as they are connected in series. The third part is the commutator. The commutator switches the polarity of the magnetic field, making the armature spin as it is alternately repelled and attracted. Finally, the driveshaft spins. The turning armature spins the driveshaft. The gearbox decreases the speed but increases torque to produce enough force to penetrate the intended material. Fleming's left-hand rule. This is a simple way of working out which way a motor's coil will turn. Stick out your left thumb, forefinger, and middle finger, at right angles. With the forefinger aligned with the magnetic field's direction, the middle finger shows the current direction, and the thumb shows the direction of the coil's turn. How fast do DC motors spin? An average DC motor spins at 25,000 revolutions per minute, but some motors, such as those in vacuum cleaners, can reach up to 125,000 RPMs. Thanks for watching. We hope that you learned something new. As always, don't forget to like, comment, subscribe and share with someone you know. We'll see you in the next video.